Hey everyone. Sorry. Hey everyone. I hope everyone had a nice we call it weekend. There is homework and a quiz on Lumen. Okay, I think if I remember correctly, I think one of them's due Wednesday. I think that's the homework. And the quiz is due Thursday, if I remember correctly. I know they're not doing Tuesday because tomorrow that is. Excuse me. Because tomorrow is a wellness day. Thank you. Right. The 17th is on Wednesday and one's Thursday. That's right. Okay. They're not due tomorrow. They're not due tomorrow because tomorrow is a wellness day. I'm not 100% sure if I'm going to have office hours tomorrow or not. I mean, it's a wellness day, but office hours is not something you're required to come to. It's only there if you need help. But you can always email me if you need to, okay? If you need to see me or speak to me or whatever reason, you're more than welcome to email me. If you do email me, though, for stuff on Lumen, please use the, the message feature, because then I can see the question that you're struggling with. And it makes it easier for me to, to answer your question, okay? All right, so that said, I know the first test is not this week, it's sometime next week. It's probably gonna be towards the end of the week. And it's gonna be it's gonna be everything from the beginning of the semester up to including what we do this week, okay? So whatever we do next week will not be on the exam. All right, and I know today we'll see the last factoring technique. So, all right, any questions on that? I don't remember if I posted the videos from last class or not. If not, then I'll definitely do it today or tomorrow. I know I didn't get a chance to post it this weekend. Again, I do apologize for that. All right. Okay, but again, as a reminder, I know we don't meet, but tomorrow is a wellness day. I think that means there's no classes, so just letting you know. But I mean, we don't meet anyway, so. All right, let me get to the notes. I did email the notes. The worksheet I was hoping we get to today, but I don't think that's going to happen. I mean, it didn't happen in the other class. Not to badmouth them or anything. I mean, the stuff we're doing is kind of long. So if you can't see the notes, again, please let me know. You know, if you can't see the slides, that is. All right. So here, we are going to see what's called the AC method. Now, we already saw how to factor. Sorry, blowing my nose. Just blowing my nose. So we already saw how to factor this kind of polynomial, this trinomial, when the leading coefficient is 1. What we're going to see now is when the leading coefficient is not 1. That's what we're going to see here, when the leading coefficient is not 1. So we have this trinomial, ax squared plus bx plus c. I mean, you technically could use this method when a is 1, but it's just going to be more work than necessary. Okay, so here's the procedure, and we will do some examples. Again, you really want to find and factor out the GCF first. It's really what you should do. I mean, on the exam, unless I ask you to find the GCF, you really don't have to. But it's really good to see what the GCF is, to factor it out, that is. Now, what you do next is you're going to multiply a times c, and you're going to find two integers whose product is a times c and whose sum is b. So let me say that again. You're going to find two integers whose product is a times c and whose sum is b. Then b, remember, is the coefficient of x. Then you're going to replace b with the sum of those two integers from step 2, what's going to end up happening is the trinomial will become a polynomial with 4 terms, and then you're going to use factor by grouping. Okay, that's what you're going to use. All right, so let's do some examples. Okay, so let's say we want to factor this first. Now, I did write down that the GCF is 1. Hopefully, you can see by now that it's 1, and why it's 1, I mean. There is a non-zero constant term. So in the GCF, the m, which is the smallest exponent of x, would be 0. In other words, you can't factor out x at all. Now, 2 and 5, if you were to list their factors, the factors of 2 are 1 and 2. The factors of 5 are 1 and 5. So the only common factor among 2 and 5 is 1. Hence, the only common factors among 5, 11, and 2 can only be 1. So 1 is the greatest common factor of the coefficients and the constant term. Hence, b would be 1. And so the GCF is b times x to the m, 1 times x to the 0, which is 1. So that's what we get. Now, so again, we're factoring this, right? And now here, in this case, we have this polynomial. So just by comparing, we can see that capital A is 5. The leading coefficient is 5. B is 11. The coefficient of x is 11. C is 2. The constant term is 2. So in other words, we get this. So A times C would be what? That would be 5 times 2, which is 10. So we want two numbers then whose product is 10 and the sum is 11. B is 11. Now it's tempting to try 5 and 2. The problem with that though is 5 plus 2 is 7, not 10. No, excuse me, not 11. So 5 and 2 don't work. What about 10 and 1? Those do work. 10 is 10 times 1, and 11 is 10 plus 1. So 10 and 1 are going to work. So as in the general procedure, what's going to happen is we're going to replace B, in this case 11, with 10 plus 1. So here's 11x, right? We're going to replace 11 with 10 plus 1. Notice I'm using parentheses. 10 plus 1 is equal to 11. 11 is multiplied by x. So the entire sum here, the entire sum, 10 plus 1, is multiplied by x. Hence, you distribute. So you have x times 10, x times 1. You're not just multiplying 1 by x. It's 10 plus 1 by times x. That's what you're doing. So we end up with 5x squared plus 10x plus 1 times x plus 2. But 1 times x, we can really just write that as x. So now we have a polynomial with 4 terms. Hence, we can use factor by grouping. Now, the first step in factor by grouping is you find the GCF. But here, hopefully, you can see that the GCF is 1, mostly because there's a non-zero constant term, excuse me, and a coefficient of 1. We've seen before that in that case, Okay, we've seen before in that case that the GCF is going to be 1 when you have a non-zero constant term and a coefficient of 1. All right. So what do? We make two groups, as you can see, right? The two terms each. And now we have to factor out each of these groups. So let's do that. So for 5x squared plus 10x, right? Notice the smallest exponent of x, right? That's 1. 5 is a factor of 10. Okay? 5 is a factor of 10. So the smallest exponent of x is 1. That tells us m is 1. 5 being a factor of 10, the greatest common factor among the coefficients, 5 and 10, excuse me, is 5. B is 5. So we get 5 times x as our GCF. What do we do next? Factor it out. We factor it out, right? Put it in front. And to get what's left over, we divide. And when you divide into each term. Now, what happens when you divide? Well, here in the first quotient, the 5s are going to cancel. X squared over x is x. X squared over x is just x. 10x over 5x, well, here the x's cancel. 10 over 5 is 2. So we get 5x times x plus 2. Good. Okay. All right, so we have that group. We're going to have to handle the second group, but right away, hopefully you can see that the GCF is going to be 1 because, again, when you factor out the GCF, what's left over in parentheses will have a GCF of 1. So x plus 2 will have a GCF of 1. And you can also argue this way because the smallest exponent of x is 0. 1 is a coefficient, right? And the only common factor of 1 with anything is 1. So the greatest common factor among the coefficients and the constant term is 1. Again, here we have 1 as a coefficient. The constant term is 2. The only common factor among 1 and 2 is just 1. So the greatest common factor, b, is 1. And m is 0 since we have a non-zero constant term. So bx to the m is this, 1x to the 0, which is 1. All right, that's good. Okay, let me just pause the recording.